Well, good afternoon, good evening, or good morning, depending upon where you are in the world, and welcome to today's webinar. I'm Charlene O'Hanlon, your moderator for today's event, and I welcome you. We have a great webinar on tap with some really interesting information, but before we get started with that, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you'll be able to access it on demand. Following the event, we will be sending out an email that will contain a link to the webinar that you can access on demand. And with that, we'll go ahead and get started with today's webinar.
All right, why don't we get going? Good morning, good afternoon, good evening, everybody. Thanks so much for joining us today. My name is Tim Buntel here from ThreatStack, and really just absolutely delighted to be introducing today Doug Cahill, who's a Senior Analyst and Group Practice Director in the Cybersecurity Group at the Enterprise Strategy Group at ESG, for an amazing talk today that's going to be based on a survey and a document that we'll share with you all at the end of the conversation about leveraging DevSecOps to secure cloud-native applications. It's a great topic. I'm thrilled to be looking at this, both the three topics that I think are really exciting, the DevOps, security, and cloud native all coming together with some great insight from the market that Doug's going to share with us, along with some of the findings that we've seen with working with our own customers. So Doug, thanks for joining us, and why don't I let you kick things off?
Great. Hey, Tim, thanks a lot. Thanks, everybody, for joining today's webinar. And Tim, I absolutely share your enthusiasm for a couple of reasons. One, I am admittedly a bit of a data geek, and so I'm really excited to share with everybody some very recent research we've just completed around leveraging DevSecOps to secure cloud-native applications. The other reason I'm excited is you can imagine being an industry analyst and looking at a lot of research data. There is no shortage of problems and challenges when it comes to cybersecurity, of course. So I look for the silver linings. I look for ways forward. And, before we jump in, I wanted to share with everybody, the thesis statement behind this study. And that was really around how can we close the readiness gap? The degree to which organizations are already adopting cloud services and cloud native applications and technologies like containers, unfortunately is way ahead of organizational readiness to secure that usage. So really the question becomes, how do we close the gap? How do we retool a cybersecurity program along the fundamental three pillars of people, process, and technology? And good news, we found some ways forward in the research. So with that preamble, let me share with you the ground that we're going to cover. So Tim and I have a lot of topics to cover. First, we're just going to take a little bit of a step back and offer a definition of cloud-native applications. Then we're going to dive into the current and future composition of cloud-native applications. So you can imagine we went out and asked the market about adoption of things like application containers, where they're being deployed, or workloads going to public cloud. So we're going to share all that data with you. Then we are going to do a little bit of a glass half empty and look at some of the challenges. So they're both operational and obviously attack surface area related challenges. Then we're going to flip the glass on its head and move into how we're going to solve some of those challenges with respect to the emergence of secure DevOps programs. And then Tim and I are going to have we're going to have a conversation throughout, but we're especially going to have a conversation around some of the best practices for securing the cloud native application lifecycle, all the way from dev time to build time to runtime. And hopefully, if Tim and I don't chat too much, we'll leave a little time for Q&A. So with that,
I'll let folks know too, with the GoToWebinar control panel, you can add your own questions as we go. So feel free, attendees, to submit questions to us that way. And if we have some time at the end, we'll go through a few of those questions. And if for any reason we run out of time, we'll definitely be able to follow up with folks afterwards too.
Perfect. Thanks, Tim. So what is a cloud native application? And by the way, is the term cloud native a bit of a misnomer? I'll explain what I mean by that. So in this context, we're not necessarily talking about cloud native companies or sort of born in the cloud companies. We're really talking about cloud native applications that fundamentally have both a technical attribute and a process attribute. So what we're offering here, and this is a pretty standard definition if you were to Google cloud native, are applications that are built on an elastic microservices-based architecture. That's the technology part, of course, and managed via an agile DevOps process or set of methodologies. That's obviously the process piece. So those are obviously two elements of a cyber program, but is the word cloud native a bit of a misnomer? It depends if we're being sort of myopic and thinking about cloud as public clouds, because cloud native applications are not necessarily deployed in and delivered from a public cloud. So one of the things we asked in this study, and I'll just share this verbally since we actually don't have this particular data set in the slide deck here, is where containerized applications will be deployed moving forward. Obviously, there's going to be a bunch of containerized apps in public cloud environments, leveraging container as a service and Kube as a service, et cetera. But actually, a lot of organizations are employing Kubernetes and their Docker environment as a form of a private cloud. And so we are seeing and do expect to see an appreciable number of containerized apps deployed from a private cloud. So not necessarily from a public cloud, could be a private cloud as well. Okay, so with that definition of cloud native in mind, let's jump into what we're seeing in terms of the composition of cloud native applications. So one of the questions we asked was around container adoption. And you can see a snapshot here about the mix of server workload types today and tomorrow. Just a couple of thoughts on containers very, very quickly. We are seeing them coming on strong. We did a similar study in 2017, by the way, and we asked, back then how many organizations were employing containers, and it's jumped appreciably over the last 2 years. Back in 2017, it was about 56% of the organizations had containers in prod to some degree, some extensively, some somewhat. Here in 2019, we have asked the same question, and we had a touch over 3/4 of the respondents had containers in a production environment. Tim, I know ThreatStack monitors container productions and workloads. Is this level of adoption consistent with what you're seeing?
Yeah, completely. We introduced the ability to have specific security monitoring for Docker containers and Kubernetes, orchestrated workloads last year, and we continue to see an uptick in that, and that's reflecting also what we see in the adoption of microservices as an architecture, right? So as more and more folks start to think about breaking their monolithic apps up into smaller pieces, and with their all the attendant challenges that comes from that, which I think we'll get to later. Obviously, that's going to be reflected in the mix of server workloads. So we've definitely seen that in all of the different agents that we have deployed.
Makes a lot of sense. Yeah, and in a similar vein, we're also seeing the use of serverless function calls like Lambda or Azure functions coming on strong as well. But when I look at this slide, Tim, and I'm curious if I had the same reaction, I'm always mindful that old technologies, save for born in cloud organizations, old technologies don't get shut off overnight, and most enterprise organizations have today and will continue to have in the future a heterogeneous mix of production server workloads. So containers and serverless do become a more meaningful part of the overall makeup of server workload types, but we're still going to have fleets of VMs and things like EC2 instances and even bare metal servers as part of the overall mix of production workloads. Is that consistent with the ThreatStack customer base?
Yeah, 100%. We've intentionally been really purpose-built for cloud native, but we do have customers that are at all different stages of that journey and continue, like you said, to have those mixed workloads too.
Yeah, absolutely. So the next logical question, we asked in the research study here is exactly where these workloads are being deployed, and we're finding a pretty appreciable shift of server workloads to public cloud platforms. So you can sort of see a migration from left to right in terms of the number of organizations that are sharing that a larger and larger percentage of their production server workloads are in fact moving to public cloud platforms. So we sort of highlighted those organizations that have more than 50% of their workloads running in a public cloud platform. So really sort of critical mass, it's not, certainly not dev and test, this is production, and it's not just a couple of applications. Now we're really thinking about, boy, this is like more than half of my production workloads are running in a public cloud platform. And it basically triples. That's what the data tells us, right? We're going from 10% today. And then over the next little while, just over the next 24 months, it's going to triple all the way to 30% of the organizations that study showing that more than 50% of the workloads will be in a public cloud platform. And along with it, of course, there was also a strong migration of data assets, from on-prem environments to public clouds. So that's a bit about
Yeah,
not only the complement.
Yeah, and just quickly, I think that reflects also some of the ways in which the security solutions have matured too, right? As the industry has gotten better about thinking how to secure some of these cloud native workloads, specifically through the big public cloud platforms, customers, I think their comfort level is increasing, right? We still have a long way to go, and some of the best practices we'll touch on here will point to those. But in general, I think today the organizations are more confident that security needs can be met as long as they do the right things.
I think that's a great point. I think we're well past the concern that the cloud isn't fundamentally secure. Now it's understanding the shared responsibility model, and are there robust, mature third-party controls that allow me as a subscriber to a cloud service to meet my part of the shared responsibility model? And totally agree with you that yes, those solutions are available to organizations today. That's a great point. Okay, so what are some of the challenges in securing cloud-native applications? What we found in the research results is that there's sort of a combination of operational challenges as well as obviously being able to fend off different types of attacks. From an operational perspective, and Tim, very interested in your thoughts here. For me, when I looked at these findings, I thought, boy, there of course never is a shortage of challenges in securing really almost any environment. But thematically, for me, the top challenges really span, again, the pillars of a cybersecurity program, the people, process, and technology components of a program. From a process perspective, there's a need for consistency for securing cloud-native applications from a sort of a location-agnostic perspective, so sort of independent where they're deployed. Having consistency across those environments is a challenge to be sure. There had been some challenges around technologies in terms of using multiple controls increases cost and complexity. So we're starting to see some convergence. So for example, controls like Threat Stack that allows you to protect both server work, both EC2 instances, for example, both VMs and containers. So that's really compelling to have that level of convergence. And then from a people perspective, it's making sure that the app dev and the DevOps teams do include the cyber teams. So that continues to be a concern. We're seeing some progress there, but respondents in the survey said, yeah, that's still one of our challenges, is making sure that the cyber team is included with the Scrum team, with the project team. And then there's just a need, the third one down here is there's some concern on a lack of understanding of the threat types, attack vectors, and the TTPs being used by adversaries that put cloud-native applications at risk. So there's always a need for cyber teams to stay smart and educated on the threat landscape, and that certainly is coming through loud and clear here in the research results. Tim, again, are these findings consistent with what you're seeing with your customers?
Yeah, 100%. I think the emergence of DevOps, these increases in velocity, the complexity of the architectures that are possible in these cloud-native world has really put tremendous pressure on security organizations. And I think one of the patterns that I see in a number of these concerns that they raise is understanding sort of what's the same versus what's different, right? What do we need to change in our processes versus how can we, sort of leverage the accumulated experience that we've had in, securing applications in other ways. And I think you see that reflected here. They're trying to figure out how do they fit into a DevOps world where it might be much more engineering driven than past ways of doing things. How do you deal with velocity? How do you deal with the reliance on third-party public cloud providers and all these things? So I have great sympathy for these organizations. They're typically understaffed, underfunded, asked to carry a huge important burden for the company, and yet are still trying to figure out how to do this in the face of really tremendous change.
Yeah, boy, so true. Of course, the backdrop is we have an ongoing acute shortage of cybersecurity skills, and it's even more problematic when it comes to cloud security skills. And that makes integrating with the CI/CD tool chain so you can get repeatability and automation, even more important to be able to solve for some of the challenges that the respondents shared here. So we also asked in the survey, naturally, what attack types were top of mind. So this is very much sentiment data. We asked both security practitioners and security leaders, hey, when you're thinking about securing a cloud-native application based on the composition that we talked about before, the attack vectors methods that you're aware of, what are the specific attack types that are of concern? And I mean, they run the gamut. It's sort of not surprising that there are a variety of attack types that cybersecurity professionals are concerned about, specifically with respect to how they could compromise their cloud native apps. And Tim, for me, when I look at this, I see some stalwarts, right, sort of exploits to take advantage of known vulnerabilities in unpatched operating systems and applications, targeted penetration attacks, malware. Those are, unfortunately, old standbys. I do think when we get to talk about secure DevOps that there are some ways to mitigate those in an automated fashion. So I'm looking forward to transitioning to how we solve for these challenges. But we also are seeing some new types of attack types that are concerned with respect to things like misconfigured cloud services, workloads, network security, or privileged accounts. So sort of that visibility gap that a lot of organizations tell us that they have when more of their infrastructure goes to the cloud. Some concern around the insecure use of APIs. So that's where we see serverless coming up as well. So we have sort of, some old attack types that continue to be top of mind, but also some new ones that are born out of what's different about the cloud.
Yeah, one thing that strikes me, Doug, looking at this particular list is how all of these really cross the entire stack, if you will, right? And we said a minute ago how more complex that stack is become, but the days when you could really just focus on securing your network or really just focus on a piece of your application are gone, because these all come together in this cloud native world to go across the domains, right? So you've got application getting down into the container that's dependent on the orchestrator that's being managed by the cloud infrastructure provider. And a lot of these cross those, right? And so the importance of being able to see that full stack and consider the security and observability and protecting that holistically, I think becomes much more important when you look at these kinds of things where they're not isolated in individual pieces of the platform.
Yeah, it really begs for a holistic approach, doesn't it? So far we talked about a definition for cloud native. We've shared current and future composition and deployment locality for cloud native applications. We've talked about some of the operational challenges, as well as Tim's point about the sort of the convergence of different attack types up and down the stack of cloud native apps. One of the next sections we got into in the research study where it was really around methodologies and process. When I write or talk about what's fundamentally different about the cloud, it's so much different than just talking about sort of on-demand elastic infrastructure and their ephemeral instances and the use of tags, sort of all the dimensions of technology that makes cloud different in the microservices, the cloud native apps. Like process and methodology is such a big part of what is fundamentally different about a cloud environment. And so where we started in this particular area of the survey is just to understand the relationship between Agile software development and DevOps. And not surprisingly, we absolutely found that Agile and DevOps adoption are in lockstep. So we did a data cut by those organizations that are extensively doing Agile and those that are extensively doing DevOps, and there was a strong correlation. 75% of organizations that are doing one are doing the other. So obviously they're using Agile as their project management approach, project management approach for the development of the software, and at a very, very high level, they're using DevOps for the delivery of that software across the different environments. So these are in lockstep. Makes good sense since we were talking to organizations that were down the path on their cloud native journey. Then we wanted to get into whether or not security was currently getting incorporated into their DevOps processes. And this is another area where we saw an appreciable increase over the last 2 years. We asked a similar question a couple of years ago in 2017, and I think back then, like those that were doing DevOps, security and DevOps extensively was something like 19%. So we've seen an appreciable jump here over 2 years. But with that said, we still have a number of organizations that are in their planning stage. And they're like, yep, we're definitely going to incorporate security and DevOps processes, but we're sort of still planning. And then that's 22%, another 20% that are saying, I'm evaluating the use cases. If we couple those set of respondents with those that have only incorporated security to DevOps in a limited fashion, I would argue that there is a need for a prescriptive approach around DevSecOps, around secure DevOps use cases, and repeatability via security as code. So what do I mean by that? So actually, last reInvent, this was last December, I was standing in line for a session, and I happened to be sandwiched between two cloud security engineers. Both were at very large organizations in the Midwest, ironically enough. And we got talking about their approach in terms of being involved in Scrum teams and working with the product owner to make sure that secure DevOps user stories got authored and they got prioritized for the next sprint. So I asked them, said, what's your number one challenge? And they said, I just can't get to every project team. There are just not enough of us who understand, from the cybersecurity team that understand DevOps and what's different about cloud to sort of replicate ourselves across project teams. So how are you solving for that? Well, we're solving that with security as code. We will join a Scrum team, and when we're implementing security controls and processes that get integrated in our DevOps processes, we're making sure that that's repeatable, that code we're developing, those scripts, et cetera, that are calling third-party controls like threat stack, are controls and code snippets that can be used by other Scrum teams. That's how we get repeatability and scale. I thought it just made a ton of sense to me. And that's how we start to solve for, that shortage of skills, and we get scale. We get scale vis-a-vis repeatability. So, while there's certainly good news in terms of the number of organizations that are now starting to use basically security as a killer application for DevOps, if you will, we still need more coverage, right? We only have 8% of organizations that are protecting more than 75% of their applications vis-a-vis DevSecOps. And by the way, I'm using sort of DevSecOps and secure DevOps interchangeably. So that's why you hear me sort of flipping back and forth between the two terms. So we have a coverage issue today. Fortunately, since organizations really are planning to embrace DevSecOps and expand their use cases from pre-deployment and runtime or vice versa, the good news is that the percentage of applications that will be covered over time really increases dramatically, right? We go from 8% that are going to cover more than 3/4 of the applications today to 35% in 24 months. So, hey, Tim, I'm wondering, in your purview of the market and working with your customers, if you're seeing a similar uptick in sort of these beachhead use cases around DevOps and it getting sort of, mainstreamed into, from one Scrum team to another, and therefore there's going to be expanded coverage of apps over time.
Yeah, we definitely are. This is a classic kind of case where you're trying to figure out how to take things that were historically manual processes and make them exist in an automated world, right? And that takes time. So we typically see our customers spending a lot of time thinking about, what are the most high criticality workloads and paths that they can start to focus on first. And in many ways, to me, this mirrors the process that we saw with software quality, right? Where if you go back a number of decades, it was the same thing with quality, where it was a late addition, something done outside of the regular dev process. Developers throwing their software over the wall to a QA team who had to be this sort of manual step before deployment to production. Obviously today that would shock anyone if you were building your software that way, but it took a long time, and folks had to think about how do you approach automating some of these processes? How do you come up with really effective ways to scale automated software testing and quality? And then how do you start to create those cultural incentives to embed it into the dev process? And I think as we have seen a lot of progress to that, there's still some more to do, definitely in quality too, but we've seen that come a long way. And I think that's what you're seeing now that security is starting to be thought of the same way. So the numbers are similar to what you just saw there. They're fairly low today, but folks are moving really aggressively based on a lot of already strong work that's been done by others to pick it up quickly.
Yeah. Yeah, you touched upon the cultural dynamic, and that arguably is where the shift to secure DevOps programs really starts. And, one could argue they're they're competing objectives. We've got app dev and DevOps teams that are charged with getting new apps and features to production as quickly as possible. So it's all about speed and agility, and the security team is typically about caution, and that can seem like a competing objective. And it really starts, I think, for me, gaining organizational alignment around security being everybody's responsibility. It shouldn't be the security team showing up with a thou shalt sort of edict on, hey, this is how we're going to start doing security and secure these environments. It's really got to be something that gets internalized by the organization. The security team needs to understand these modern methodologies that are providing tremendous business value. At the end of the day, we can't be slowing the train down. We've just got to integrate into those processes that are already being employed. And really, security needs to have a seat at the table. And that starts with having a champion on the product team, typically the product owner. But boy, you can't overstate the cultural dynamic here and really getting everybody on the same page that security really is a shared responsibility. Everybody owns it. Everybody's got to dig in and take responsibility for it. And that's a good segue to talk about some best practices. To do so, we wanted to sort of frame up, one perspective on securing the lifecycle of a cloud-native application. Quite honestly, when I was looking at the slide again, this was a chart that we had made a little while back, and it's pretty good. It's appropriate when we think about going from dev to test to staging and production. The reason I'm being a little hesitant is I think there's a design phase on the left. So I think we're going to be updating this because I think in the design phase, and this goes back to sort of writing user stories, is we want to be baking in security from the get-go, right? We want to be thinking, hey, when we do ship to prod, how are we automatically applying runtime controls to protect those server workloads and containers in production? And that really needs to happen, for me, in the design phase. So as we go from dev into test, and we're starting to stage, and we're doing pre-deployment checks on hardening configs and bringing out vulnerabilities. That's all been thought about. So it's not an afterthought. It's like, we're sketching out our sprints, running those user stories in our design phase. Security was absolutely baked in from the get-go. I guess my other commentary on this slide is, very often the term DevSecOps has been associated with the term shift left. And you can see with, the arrow on the bottom, we're absolutely connotating shifting left, but I think sometimes shift left is a bit of a myopic view of secure DevOps. It sort of implies AppSec, methodologies in the dev phase where you're doing composition analysis and bringing out, inadvertently introduced vulnerabilities by the dev team. Absolutely a really important part of a holistic DevSecOps process. But I just think it's an incomplete view of DevSecOps. And there's a little bit of controversy in the market around the term DevSecOps, and part of it is, well, what does it mean anyway? And that's why I'm offering this editorial comment here. Is to me, it means more than shift left. It also means stay right. Meaning we also have to have runtime controls, and that's really the point of this graphic, is to secure the full life cycle of a cloud-native application. A secure DevOps program will span the full life cycle, going from design to dev to test to staging to production. So you're shifting left and you're staying right.
Yeah, I actually. Sorry, Doug. I just wanted to chime in on that one. I'm 100% with you. I think the phrase "shift left" came out, and I think some folks took it to a kind of an extreme conclusion and said, well, that means that developers own security now, right? We're just going to empower the developers. They're going to figure it all out on their own. And I actually like the way you have this graphic here, because it makes it clear that it's not lifting it out of security at the end of the process and plopping it in the dev stage. It's really about figuring out how to embed security throughout the entire process, right? So it's spreading security as just a natural part of every stage of the software development and delivery pipeline. And it should go all the way, as you said, from when you're first thinking about the features to when you're coding, testing, deploying, and then revising, starting that whole cycle all over again.
Absolutely. This should be a continuous cycle. I mean, just like we talk about continuous integration, continuous delivery, security should similarly be continuous. And A little later, we're going to share some best practices by stage, and we can get a little more specific about, integration with the tool chain. What exactly are some examples of the tools, the DevOps tools that are being used at every step of the way, and what are some of those examples of integrating with those tools that would then get manifested in a user story and then prioritized for a sprint. So one of the things, Tim, I was interested in conducting this research was where organizations get on the secure DevOps bus, if you will. I was sort of wondering, okay, given the discussion around shift left, do more organizations start pre-deployment? They think sort of secure DevOps is all about pre-deployment. Or if they're coming from, an enterprise context and they think more runtime, are they getting on the secure DevOps bus in runtime? Are they mutually exclusive? Are they both valuable? And basically, for me, they're both legitimate. I mean, ultimately, you want to secure the full life cycle, but I just think, you ought to start small. You ought to start somewhere and expand from there. Don't be overzealous. Don't try to secure everything right out of the gate. Get some wins under your belt. Establish some repeatable code so you can scale over time. And so the respondents told us that. So yeah, we had the same number of respondents, basically rough and tough, that were starting pre-deployment or starting at runtime. And so from there, we wanted to double click on that and say, okay, well, what are your top pre-deployment DevSecOps use cases? And, for me, this is all about having hardened configurations pre-deployment. So when you push to prod through your orchestration tools, Chef, Puppet, Ansible, or Kube, you've got a high integrity workload or container that's getting pushed into prod. It's all about hardening at the end of the day. And, we talked earlier on one of the problem slides about one of the top challenges being gaining visibility into the configuration of workloads. That's certainly part of it, comparing workload configs against CIS benchmarks. And we can see here that, the number one issue was software vulnerability scanning of registry resident images, vulnerabilities in APIs, but also software vulnerability introduced during the build pipeline, and then discovering the use of APIs in source code. So this is a set of pre-deployment use cases. And then naturally, we wanted to ask our respondents, hey, what are your top runtime security use cases? And Tim, you want to take this one? I just chatted about pre-deployment. I'm curious about whether or not these responses are consistent with what you're seeing with the threat stack customers.
Yeah, absolutely. Those are definitely the kinds of things that folks are focused on. One thing that we work very closely with our customers, in addition in the build time, is to remember that infrastructure itself is something that you have to remember about securing, right? So all of those parts, your automated CI/CD process, your testing infrastructure, your staging environments, all of these too are potential risk. And as we go into a cloud native world, they're increasingly central to your success as a company. And so we make sure that folks are not only thinking about how do you build security for the end product into that CI/CD pipeline, but how do you think about securing the actual assets that make up that CI/CD pipeline? Think about secrets management, thinking about how powerful a CI server is because of its connectivity to so many other key systems that deliver the software. So thinking about not only baking security at build time into what you're ultimately going to deploy to your customers, but thinking about the infrastructure that makes that automated pipeline possible.
Yeah, boy, such a great point. I mean, it reminds me, just in an on-prem world, the imperative to protect your domain controller, right? You want to have a absolutely a least privilege model for anybody that has admin access to key stores that are really crown jewels. Similarly, it's the same sort of issue as you mentioned here in a cloud native world. They're different entities, but it's the same sort of risk profile that those systems represent as an AD controller. The other interesting things on this slide, for example, is the 26% who said, hey, one of my top runtime DevSecOps use cases is system activity recording for incident response. It's just interesting in a cloud environment where containers and VMs are coming and going, they're temporal. And if you wanted to go back and at an incident response fashion investigate the attack chain, that system is no longer alive. So you do need the ability to record system activity so you can play the tape. And then like the 23% who noted exploit detection and prevention is one of the top runtime use cases. Like one of the things we need to be looking at is the merit of anomaly-based intrusion detection in these environments. When you're scaling server workloads in an auto-scaling group, it's like having a gold image in an old environment, right? Where the sort of runtime profile ought to look the same. There should be no deviation from process behavior, net flow, et cetera. So, which is just to say that there are sort of new approaches and ways to be able to solve for some of the use cases that we see on the slide here.
Yeah, we see in our own world how these are all connected too. We have a co-managed service here that works with our 24/7 expert staff center that can help our customers find a lot of these types of use cases, focus on them, but you don't see them in isolation, right? So, for example, we did a webinar a couple months ago on a Docker cryptojacking exploit that the team here had detected in a customer's environment. And it involves all of these, right? They all come together in real life in an attack, right? So you've got a vulnerability in the application tier that allows a command injection attack, and then they take advantage of spawning an unauthorized process in the Docker container that allows them to go out and download their crypto mining software. And all of these things kind of fit together. So you have to remember that you can't see these use cases in isolation. You have to think about how an attacker is thinking, how can the weakness in the software tier allow me to take advantage of something that's happening lower, ultimately being able to do data exfiltration through an API, right? So it all comes together and requires this kind of full stack security observability piece that we talk about here at ThreatStack.
Yeah, you mentioned container images from a public repo, and your point about all these dots connect, you got to have an integrated approach, just reminds me of the need to, even more so in this world, to secure the software supply chain. Because very often, the developer that very often is making the choice on the composition of a cloud native application, including third-party libraries and open source components and container images from public repos. And therein lies where there could be the weak vulnerability that it could in fact get exploited. So I think that's the other sort of dimension.
We're setting the developers up for that, right? We're empowering them to move fast, be independent, go and solve problems quickly. And so we have to expect that they're going to go and look for a pre-built container image that kind of has what they need, and they're going to run with it. So it's up to us to give them the guide rails so that they can take advantage of that speed, but do it securely, and have a little bit of guards around that.
Yeah, absolutely. And those guardrails, when they come in the form of third-party security controls, need to be integrated with the tools that dev team is already using. I heard recently a story, and I imagine this is fairly common, of an organization trying to use a traditional network-based firewall to segment off their containers. It was a highly dynamic container environment, and so there were just tons of IPs getting generated. So they weren't using roles or tags; they were using IPs, and the firewall crashed. It just didn't. It couldn't scale for that type of dynamic elastic environment and just that many IPs, because that wasn't purposeful for that environment. It wasn't designed for that type of environment. So that's probably a good segue into this slide. Tim and I wanted to be a little prescriptive on offering a handful of Agile user stories sort of by environment. So this is meant to be, sort of the framework, if you will, sort of really large grain framework for some user stories that could get authored into Jira for your next sprint. So, at dev time, we were just sort of touching upon this in terms of doing composition analysis. So you basically have a bill of materials for all the elements in your source code. Doing static code analysis just to verify that no vulnerabilities are being inadvertently introduced by your dev team. You'll find tools there that are integrated with that phase of the cycle. Will do things like they might even highlight what code, what line of code introduced the vulnerability right in the IDE. They ideally would open up tickets in something like Jira, then and route that ticket right back to the developer who wrote the code. And then in the in a test context or pre-deployment, like we mentioned earlier in that particular slide, it's really about hardening or reducing attack surface and build time. So it's about eliminating all known vulnerabilities, so both software and configuration vulnerabilities. And by the way, it may be that there's a policy that says not only just on the CVE, but based on the severity, the CVS, that we are going to push that app into production. At least we're going to monitor that application for that vulnerability being exploited, but we're making an eyes wide open decision that the vulnerability isn't that secured, and we've got a time to market consideration or some sort of SLA that requires us to push. But at least you have visibility to know what's going into production. And Tim, I'll touch on prod really quick, and then ask for your thoughts here, because I know ThreatStack obviously is really indexed in this particular area. But this is all about policy-based runtime controls, where maybe you're using things like security groups or microseg to implement least privilege, a variety of anti-threat models. I mentioned sort of made the case for why anomaly detection is an appropriate approach as intrusion detection technology for these types of environments, auditing. And again, this notion of policy based on tag, which denotes typically the role of a server workload, and that provides consistency and scale over time. So, Tim, I sort of riffed through those really quickly. And I know, like earlier, you made the point that, hey, security too often is bolted on. We gotta build it in, and that's what I mean by the Pringles can here, right? Too often security looks like this, and we're sort of suggesting if you start to have these automated security DevOps use cases by these environments, your security program isn't going to look like a Pringles can.
We understand, we're working with security organizations at a range of companies, from small scrappy startups to really well-established enterprises, and I think they all try to find this balance, right? There was a survey done at RSA this year, of sort of what are roadblocks to implementing application security programs, and the number one response was around this kind of fear that security programs were going to impact the agility and speed of the application development itself or deployment, right? And this is that balance that we have to strike. We know that there are these good practices that we can help derive from the security side, but they're only going to be successful if they get adopted by the engineering organization and the operations team. And so, again, it's all about finding ways to reduce the friction for adoption, automate where possible, give guidance, and not be overly prescriptive. And I think that's captured in all three of these phases, both all the way from dev through test and into production. Which I think we're probably going to touch on again here. As you were talking and going through these, these are a couple of the points that I found to be kind of most important things that would point out. So I'll kind of give my perspective on these, and I think clearly these all tie in really well with the research that you did. So again, as we talk to our customers, emphasizing what you were pointing out at the beginning is really key, that there is a difference between cloud native and on-prem or traditional environments, and solutions that were appropriate for other types of application architectures and different types of infrastructure may not be appropriate for cloud. So really thinking about purpose-built, designed with this awareness of being cloud native is critical. We were just touching on this notion of build time and runtime holistically. Again, if I can find a way to help my developers do it right from the beginning and then not have to think about it as they move forward, boy, that's going to have a huge impact just in reducing the risk, reducing the friction from them. And then it'll allow the security teams to really focus on the higher value stuff rather than trying to beat up developers about taking the appropriate steps that they should from the beginning. We did touch on containers a bit. Obviously there's heaps of things here, and a lot of folks think that by slapping security or slapping an application into a container, it's inherently more secure. But we saw with the Run C CVE earlier this year that really was a pretty devastating one for folks who who may have been faced with that's not necessarily the case. And a container by itself, through the architecture alone, doesn't give you security. And thinking about what are the OSs that you want to use in containers, and not necessarily using general purpose OSs, and a host of best practices there that folks should think about. Obviously, this is sort of cultural piece at number 4 was a huge one throughout the conversation, I think, today. But for me, I've always found it ironic. I've been building software for IT teams for my whole career. And this is one area where I honestly believe that you can't buy a product to fix this or to solve this problem for you, right? You can't, product your way into security. This is something that requires an organization and philosophical approach, and it can't just be isolated in this, little team that sits in a corner on a separate floor. It's something that has to be integral to every aspect of the application. And then I think, go ahead, Doug. Yeah, it's going to lob it to you.
No, I was just going to amplify that point, Tim. I think part of it is that, app dev and IT in general is becoming decentralized. And so cybersecurity can't be centralized anymore. It needs to be decentralized. It's got to be, embedded within those teams as a sense of ownership. So cultural shift is a big deal here.
And luckily for us, I think to this last point here, there are ways that we can do this that are not as reliant on the sort of face-to-face, heavy touch, heavy interference role that security might have played in the past. By thinking about ways to leverage, immutable infrastructure and the way we represent other parts of our infrastructure as code, thinking about making security follow some of those same practices and processes, allows it to scale in a way that's going to meet the demands of doing this at DevOps scale, right? That time between development and production, that build versus runtime, is shrinking, and the gap is getting so small that it's almost imperceptible. So if you can't find ways to put these practices in place in a repeatable and scalable way, you're really going to struggle.
Yeah, totally agree. But at the end of the day, I'm an optimist. I just think that integrating with every phase of the CI/CD pipeline is an opportunity to bake it in and really move the needle. And got to start small. Got to codify it. Got to implement security as code for repeatability, and an eye toward how that code can be used by other Scrum teams. But then, to your point, Tim, you can scale. You can DevOps securely. Absolutely. And really, for me, it's really an opportunity just to sort of flip security on its head. Everybody's responsible for it. It gets planned at the design phase. It gets incorporated every step of the way. And that's why I find a lot of the research results, really encouraging. And so I hope everybody who's attended today has, found some solace in this peer-level research, that there are, in fact, organizations that are really starting to leverage secure DevOps programs, both pre-deployment and runtime, to secure the full stack across the full lifecycle.
And I'll be linking in the next slide here to the research that you produced there, Doug, on our site. And we will put the recording of this session online shortly after we finish up today, so folks can follow it up there. Obviously, I think this conversation has been great in that we've been able to explore topics that are way beyond just us as a vendor, or sort of the space that we play in. But definitely, what we look at ThreatStack touches on many of these parts. So, we talked about the complexity of some of these environments, and ThreatStack really works hard to view all of those signals that are produced by modern software development practices leading to cloud-native applications. How do we pull those signals in? How do we help customers make sense of them and be able to act on security problems, both proactively and reactively, when they happen in these environments? So definitely, if folks are on the call today who are not familiar with ThreatStack, we'd love to have you reach out, and we'll tell you more about how we fit into this whole landscape of kind of emerging aspects around security for cloud native applications. So I'll advance here and put the URL up if folks want to seek out the report, the ESG report. We've made it available on the ThreatStack website, and there's even more content that we weren't able to cover today. As much as I really appreciate the points that you pulled out here, Doug, there's just tons and tons of good information there. So if folks are looking to understand what their peers are facing as they're thinking about securing cloud-native applications, this is a great resource to take a look at in that. So let me see if there's some questions here. I think we might just have time for one or two questions before we go. So there's one question around the difference between serverless and containers. Doug, you want to take that? I'm happy to speak to it as well.
Yeah, Tim, I'll take a crack at it, and interested in your take as well. It's a great question because the term serverless is a bit of a misnomer. It's a confusing term. It's just a sort of esoteric concept. End of the day, it's an API. It's an event-driven function call that is getting run on a server that the CSP is managing, not the customer. So, I think of the difference of sort of containers and serverless on how long you want your code to persist. Serverless is typically milliseconds, and containers is seconds. So that's sort of one way to differentiate between the two. What do you think, Tim?
Yeah, and we see this as well with our customers who are really thinking about how do we continue making the most of a microservices architecture, right? And ultimately, it comes down to, as we look at the overall experience that we have to deliver to customers for value, what's the most efficient way to break that up into pieces, right? And for certain types of functioning, a function as a service, right, which is serverless, so that pure execution component of business logic that the host platform manages entirely for you. That's great for certain discrete parts of processing or task-oriented functionality. But then there's still, high degree of likelihood that there's going to be some other parts of that architecture where you want to have a little bit more control about creating the entire environment that you package up. And for that, containers are great. And then there's even the sort of hybrid, right, where you get to something like Fargate in AWS, which still takes the container as the deployable unit, but takes the philosophy of function as a service, where you're just saying, allocate a certain amount of memory and run this container as required. So it gives you the simplicity from an operations perspective of function as a service, while still giving you a little bit more control over the runtime environment that you would have in a Docker container. So we're seeing a lot of our customers looking into to Fargate for that reason too. Okay, and maybe we got one more here before we wrap it up. So interesting question here on the focus for cloud native and public cloud, but obviously enterprises also have the idea of private cloud and public cloud. So maybe Doug, what do you see in the survey data or in your interactions with clients around the way enterprises are thinking about that in the long term, specifically the private cloud versus public cloud?
Yeah, I meant to hit this point on that prior slide. I think what's at play here is the promise of portability of containers. Not so much with serverless, by the way. You tend to get locked into that particular CSP. The more serverless functions you're embedding into your source code, but containers are, at least in theory, portable, so you can be running those across multiple public clouds or even on-prem. And so the reason I mention that is because when I saw the research data that showed that public cloud is where containers start, but moving forward, a large percentage of organizations said we intend to deploy containerized applications in a combination of environments that we manage, on-prem data centers or colo facilities, and public cloud platforms. I thought, that means they like the portability, they want the optionality. I also think it means they're not necessarily sure yet. They have this sort of design center where they want it, those applications to be location agnostic. So maybe they can move them around based on best fit of the underlying platform, or maybe the cost structure of the underlying platform. So it's about portability and having that option, and not necessarily knowing yet exactly where containerized applications are going to be deployed. And what that means, by the way, is you want to make sure the security control you're using to protect your containers is as equally portable. That was actually the number one challenge for container security was I want to make sure I've got alignment with where I'm going to be deploying containers. So like to Tim's point, if you're going to be using Fargate, or if you're going to be standing up your own Kube cluster on-prem, you want to make sure that your container security control is can travel with your containers and be portable as well.
Great. Well, I got to really thank you again, Doug. This has been a great conversation. The data is really fascinating. I do encourage everyone to go and download the report at the URL there. But otherwise, Doug, again, many thanks, and we look forward to having a conversation again with you really soon.
Absolutely, Tim, my pleasure. Thanks so much.
All right, great webinar. Lots of great, interesting information. So I did want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or you just want to listen to it again, just know that you'll be able to do so on demand. We will be sending out an email that will contain a link to the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always check there. And then while you're there, you can check out the other webinars that we have, both upcoming and on demand. Hopefully there'll be one or more that pique your interest. For now, though, I'd like to thank you for joining me today, and thanks to our esteemed panelists for joining me. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.